Hello, good morning, good day, good evening, wherever you are watching this presentation. My name is Jürgen Thomas. I'm a partner architect in SAP, in SAP on Azure Core Platform, or more precise, in Azure's core development. My team and I are responsible for SAP workload on Azure, reference architecture, certifications, and a lot more. We're talking about new insights for migrating SAP and SUSE workloads onto Azure today with a focus on SAP as a workload. If we look through the customers that we have running SAP on Azure, we find that we have, first of all, many of them, many customers that are running whole SAP landscapes, their whole SAP landscapes, or parts of the SAP landscapes in Azure, starting very small in terms of footprint in Azure, and then becoming larger and larger with deploying more and more SAP systems in Azure until they are finally finished with their whole SAP landscapes, or using Azure in the first instance as an DR data center, as a virtual data centers used for disaster recovery, and later on moving their real estate, the production real estate, into Azure as well. As we look through the different companies that we have presented here as with their symbols, you see a lot of companies out of different industries, different countries, different geographics. It's really across all the industries, starting with consumer goods, looking into the energy sector, looking into banking, insurance, health, and pharma. So you see, it's a lot of different companies, a lot of different industries that are using Azure as basis, as a virtual data center to run SAP applications or the complete SAP landscape in Azure. I think we forgot one symbol here, that is Microsoft itself. No doubt about Microsoft. We have a rather large real estate in SAP landscape with way over 100 different and distinct SAP systems. No doubt about Microsoft leading the pack, having the whole SAP landscape already in Azure for quite a few years, and working very closely with Azure development and really give feedback into development to make sure that we as Azure development are developing in the right direction, developing the features and functionalities that an SAP application needs in Azure. As we look into the way how the different SAP customers move into Azure, we see very different notions, very different motions by the SAP customers. So the most simplest is that some of the customers are moving in a lift and shift motion into the cloud. That means they are running on NetWeaver, have a database that is not necessarily HANA at this point in time, could be a SQL Server, could be Oracle, could be DB2, MaxDB, SAP ASE, and a customer simply move into Azure. Very often triggered by the fact that eventually hardware investments would be required for the hardware that's on premise to have a hardware that's in maintenance again. And it's something customers eventually don't want to do, and hence they are moving into Azure infrastructure as a service with their existing SAP footprint. Operating systems, Windows, but also a lot of SUSE, Linux that we see moving in that way into Azure with DB2, with other databases. Other customers choose a different way, including a lift and migrate, where a heterogeneous operating system or database migration is necessary. Thinking about P-series customers with AIX, their heterogeneous database migration is necessary as they move mostly to Linux, very often to SUSE Linux with their DB2 systems into Azure. Very large systems that we gained with that. Another motion is, and this already includes HANA, where we see customers having, that's PAF-C, customers having HANA on-premise already for quite a few years. having bought appliances that are going out of maintenance, and so customers would like to move their HANA installation on NetWeaver into Azure in order to run the SAP HANA database in Azure together with their NetWeaver. And then we have the fourth way, as we see customers transforming their businesses and putting up greenfield implementations of S/4HANA in Azure in order to then move their NetWeaver business functionality into S/4HANA. We see customers doing it many-fold here. Many customers are moving their NetWeaver at the same time as they put the S/4HANA systems in a greenfield manner into Azure, so that everything is playing in Azure. Means very dynamic landscapes, very dynamic infrastructure as a service utilization possible as the number of S/4HANA systems is ramping up on special HANA certified infrastructure in Azure, VM families that support very high amounts of memory. The customers are able to ramp down their NetWeaver infrastructure by simply resizing VMs to become smaller and smaller and smaller, or deleting virtual machines in the application layer as they are not needed anymore because business processes were transformed onto the S/4HANA side. At the same time, they can ramp up their S/4HANA side, especially with increasing demand for memory. They can choose larger and larger virtual machines that satisfy the needs and the requirements for their memory. At the same token, strap up more applications or virtual machines. It's a very dynamic environment to have NetWeaver as well as S/4HANA in Azure as the transformation, as the business transformation takes place. When we look into migrating an SAP landscape into Azure, we always go through the same phases. As we start with the on-premise landscape, we are going through a discovery phase. A discovery phase where we look into the real estate of the customer, look on the systems that need to be transferred into Azure or lifted in and migrated into Azure. In a preparation phase, we also do an assess of the plan. There might be release combinations that are not supported as such in Azure, that might relate to operating system releases, that might as well relate to very, very, very old SAP releases like a 4.6c that we are unfortunately not supporting in Azure at this point in time. There also might be areas where you want to do a right sizing. So in terms of performance, in terms of throughput that you need to provide with a system, you might realize that on-premise systems were eventually oversized, but they might have been undersized as well. So basically in the prepare phase, you figure all this out: operating system combination, SAP release combinations, sizing that you want to do, high availability architectures that you want to apply to that system, to your landscape. And then in phase of migration, it's really all about moving this, deploying the infrastructure and moving the data up into Azure, testing the recovery, testing the high availability, testing performance, and then finally do the cutover. Then we are in a run phase in Azure where we want to optimize the landscapes. We want to ideally being a steady cycle of figuring out how to save money, how to make the TCO better with innovations that come with Azure on an annual basis, on a half-year basis, that eventually really have a big impact on TCO. So you really optimize, you in a steady kind of cycle optimizing your landscape. And then you certainly want to innovate by integrating services that are in Azure, by getting insights with AI, ML tools of Azure, analytics tools of Azure. In all those phases, we do have solutions. We do have partner solutions. Some of them we have on our own. We certainly are able to provide the whole package through our partners and through our tooling that we do have specifically for SAP. As we look into the operations models that SAP customers are applying as they move into Azure, we see all the three different models that I'm showing here, starting on the left-hand side with a customer managed model. For example, Microsoft's doing that. We have our own basis team. The basis team is managing the infrastructure deployed on Azure so that the very fast turnaround cycles possible. Our basis team in Microsoft has all the permissions and privileges on Azure to create new VMs within the boundaries that the network department set them in terms of VNets, IP address ranges that our basis team cannot change. Our basis team can create new storage on Azure so that they can clone systems, they can create new system landscapes for project teams in a very short manner. Then we see the approach of a lot of customers that use a partner to manage their operations of the SAP landscapes in Azure. Very often the same partner as they used already on premise. These customers very often had already partners that they had a relationship with, and so as we work closely with a lot of these partners, and try to enable these partners to run SAP workload, to manage SAP workload on Azure. There's a large selection of these partners available for customers that decide to go the way of having a managed service provider for their SAP landscapes in Azure. And then as a third possibility, we certainly have the possibility of a SAP managed SAP landscape through services like SAP HANA Enterprise Cloud. Yeah, that's in principle the way how we see customers being deployed in Azure with the SAP landscapes. As we look into the partners, you see we have different layers here. Certainly, a large amount of global partners available, as you see in the top box. We do have awesome relationships with a lot of partners that are more regional and local system integrators, where we work that are all trained, that are all savvy in deploying and managing and operating SAP systems and landscapes in Azure. So huge, independent of your geographics, a huge amount of partners available here. Now, as we look into Azure itself, when we look into the prepare phase, we talked about you want to do right sizing. You need to figure out what do I need if I'm running my NetWeaver on Oracle or NetWeaver on DB2 on SUSE in Azure. As I transform into HANA, what is my data volume that I have in HANA? What is the memory demand going to be in Azure? What is the memory demand for the specific VMs that I have? From an Azure point of view, there is a huge bandwidth of VMs that we have available. You look at the lower left where we have the smaller VMs, as I call them always. These are usually used for, well, the application layer, where you use VMs with 16-ish CPUs, somewhere between 64 and 120 gigabyte of memory, eventually going a little bit higher here and there. But it's usually the application layer that you build up in a scale-out manner. As we look into the database space, traditional databases, we often see customers using our E-series, where we also have some of the SKUs certified for HANA, but usually that's where you can run mid-range systems, somewhere units that deliver you around 70, 80, 90,000 subs already, so quite beefy to a degree. Memory up to 672 gigabyte here. And then in the middle, you see the bread and butter HANA certified units going from 192 gigabyte to 4 terabyte. A lot of deployments here, especially with SAP HANA, running smaller to mid-range HANA system in a reliable manner. Some of the units are certified for OLAP scale out as well, so that you can go up to 16 nodes here and pair them together into a scale out SAP HANA configuration. As we go up the stack here a little bit, we go to the larger VMs that we have to really get into the high end, where we have 3 terabyte, 6 terabytes, 12 terabyte machines, or VMs that are delivering up to close to 500,000 subs, 480-ish to be more precise, used by quite a few customers. We do have scale-out certification as well, for example, for the 12 terabyte unit, where we do have customers that use 3-node sub-car scale-out or S4HANA scale-outs here. And for capturing the absolute peak, going to the maximum of what SAP HANA does support on a single instance, we have a hardware as a service offer. That is where you can have up to 24 terabyte per unit. That is also a service where we can offer Optane memory to Intel persistent memory called Optane that can be used for stretching memory a little bit further. We offer different ratios between DRAM and the persistent memory with this service as well. So we are basically set on the whole bandwidth that can be easily used, combined, and that definitely has a huge, provides all the growth potential necessary for large deployments, even as HANA data volume is increasing, as memory demands are increasing, no doubt about it. So the other area where you can scale very well is on the storage area. We have different storages available that can be ideally used for SAP, that are used very heavily, but then also storage that's a little bit more special, that covers special edges that are sometimes necessary or sometimes demanded by you as a customer as well, or by customers in general, or by partners as well. When we look at the right-hand side, we have a standard HDD, standard SSD storage that we don't recommend for any database loads. That is usually okay for kind of backup or something like that. Where it really is becoming interesting for databases, usually our premium SSD storage, which is the storage that mostly is used for databases, very cost efficient, provides sufficient IOPS, sufficient throughput, and latency that's usually sufficient for, especially for HANA, where we have KPIs or databases in general, where ideally the latency on the redo logs or transaction log is below a millisecond. We can provide that with this storage without any problems. Storage is available in all the regions. So principally bread and butter storage, premium SSD, ranges onto disks of up to 32 terabyte, used a lot. Most used storage in conjunction with SAP environments. We look into Ultra Disk, which is storage where you can define, where you can provision IOPS, throughput, and volume or capacity of a disk, and can basically build and handcraft your disk. You also can change those throughput and IOPS provisions on the fly, so that you could adapt to certain workload. Super low latency storage, less than a millisecond, very fast, HANA certified as well. Usable very well, have some customers using it, especially on the redo log side, but also in order to get very, very fast save points written on HANA side, used at that space as well. And then we have a shared storage NFS called Azure NetApp files, where we provide NFS 4.1 shares, very low latency, high throughput storage, specifically for databases, with a lot of functionality that customers know from NetApp. So very attractive for customers that build their operational concepts of NetApp functionality, like SnapMirror and so on, and these kinds of functionalities. Also, That is storage that enables us as the only hyperscale provider to build out HANA scale-out environment with standby node. We are meeting the KPIs of less than a millisecond with that storage. With that, we then can build these nice scale-out environments that have a standby server or two, like we have a customer that runs a BW on an 8+2 node scale-out cluster. What about our innovations on storage? Innovations are steadily coming, as I mentioned. You need to do right sizing. You need to look into what changed again. So, for example, like in premium storage, we have the ability to change so-called performance tiers. When you look at premium storage, the performance, the IOPS and throughput comes in certain tiers that go with the size. You can now, without changing the size, change the storage tier to a higher one, so that for a weekend or for some operations like release upgrades of S4HANA, you can push higher IOPS and throughput numbers on the very same storage, on the very same disk, and take it down again online without a problem. We also have an on-demand disk bursting in public preview for our large premium SSDs that allow you to burst a single disk up to 30K IOPS and a gigabyte a second on throughput. Or we have a VM level disk bursting that we introduced for smaller VMs that we are going to introduce for our larger HANA certified M-series VMs as well, that allow you to burst beyond the quota that we usually have for a VM for storage throughput. So bursting in all areas possible. And that we usually see is then relieving a little bit on your design constraints and make operations way more easier and smoother. As we look into high availability, especially around SUSE, we are looking into different pacemaker, usually as the high availability functionality in Azure, as you do that on premise. In terms of the usability, we do have several alternatives. The one is that you provide a highly available NFS clusters by taking two VMs, attaching premium storage to them, and use the RDB as delivered by SUSE as a replication mechanism. And with that one, you get a nice NFS share that's highly available. But meanwhile, we are also offering, as I mentioned, NFS shares as a first-party service, so to speak, based on ANF, that you can use as well for building a pacemaker cluster for SAP's ASCS ERS as well. And then we are working on getting into general availability of another possibility of NFS shares, not as super fast or in terms of latency as ANF, but eventually a little bit more cost economic, and NFS shares based on Azure files, not yet for production usage, but it's going to. But as soon as it's general available, we can do that. A very unique thing that we have as well documented is a so-called multi-SIP cluster where you can build out of two pacemaker clusters, or two nodes, two VMs, one pacemaker cluster, that you can host 5 instances of ASCS, SCS on this one cluster, and with that, lower the footprint dramatically and the costs as well, lower number of VMs, obviously. If you look into the different possibilities that I just mentioned here, they do have different features, functionalities. So, for example, our NFS on Azure files is coming with the possibility of a zonal replication, means between the availability zones of Azure we do a replication, which then means that that you have a higher availability. On the other side, NFS on ANF is providing cross-region replication based on SnapMirror functionality. And so with that one covers functionality that the other one, NFS on Azure files, do not have. So different possibilities, different functionalities for different demands, different requirements, and the choice is basically yours. Another area that we see in the migrate deploy is basically the deployment of the infrastructure, the installation of the SAP software that we want to simplify. So basically we are taking an approach of infrastructure as code and configuration as code. Code in form of Terraform and Ansible, respectively. In order to do that, we opened a public repository that is publicly available, and we are developing modules in form of Terraform for the infrastructure as a code and Ansible as configuration as a code that we make available for the public. We make available for partners. We make available for customers that want to use those modules. We are providing in those modules configurations like storage configurations that we basically sanction and tested, as well as the Terraform and Ansible modules to deploy them. You are doing the orchestration. You can do changes. You can get your own branch of the GitHub repository, can do changes accordingly. Goal, no doubt about, is to get to a state where we can automate the deployment of any of the SAP software with an infrastructure on Azure in an automatic manner, in an automatic fashion. Another area that we are investing quite a bit is Azure Monitor for SAP solutions. This is a product in public preview. It's available through our Azure portal via the Azure Marketplace. So basically the idea was to say, look, in Azure we are collecting a lot of infrastructure data, and infrastructure data that, if you look at it, could explain, or infrastructure telemetry that eventually could explain why the SAP application behaved in the way it behaved a day ago, an hour ago, or half an hour ago. So what we want to offer here with Azure Monitor for SAP are possibilities to collect data within the VMs where your SAP application is running on, and mix that data up with telemetry data that comes from Azure Monitor that we anyway collect already about the infrastructure. When you look into the specifics what Azure Monitor is collecting, then we look into data of SAP NetWeaver. So basically, memory consumption, utilization of work process, these type of data that we have, that we get out of SAP NetWeaver. By no means it's collecting data about individual business processes. That's not the goal of the whole exercise here. It is more data around the utilization of an SAP instance, application instance, or batch instance, whatever. SAP HANA is a database collecting data from there. SQL Server is a database as well. Pacemaker, where we worked with SUSE, to get excellent monitoring for pacemaker cluster mapped into Azure Monitor services. And then from general data from the operating system, from the Linux operating system, that we are basically collecting and then moving through some pipes into the Azure portal where you can visualize the data and analyze that data and correlate data on a timely manner between infrastructure and SAP application or database. No doubt this is a continuous development here as well. Having HANA and SQL Server as databases is not the end. We will add more functionality, more monitoring, and more variations here as well. And here we have some resources so we can get started with AMS and have some documentation about it, as well as some videos. Another area where we invest into is Azure Backup Service. This is Azure Backup Service that exists since quite a few years, What we added over the time, especially with the background of SAP, is HANA, backing up HANA as a database, where we use the backend interface for it, because customer demand was clear. We could do excellent. We could do backups for VMs already, and VM snapshots already. But what we could not do is to deal with HANA databases. And so that is something that we added to the tool, supporting the backend interface, supporting different backup types. Certainly having a long-term retention administration, having access controls, so being a real backup service that you can use for managing, operating, creating backup policy, logging the backups and all these kinds of things, logging the retentions, and so you a real backup service instead of like just an adapter to backend, as we see that with some of our competition here. Again, there's ample of documentation out for this backup service, starting with running the backup, restore guidelines, and all these kinds of things. So, well, time's over, I guess. There would be way more to talk about, especially in combination with SLES. But hey, we'll see that we see us the next time. Thanks a lot for your attention. Really appreciate your time. Goodbye, good night, a good day, wherever you are.